graphing y equals minus a half sine x over 2. General equation for sine function is y equals a sine open bracket bx minus c close bracket plus d. In this case, a is the amplitude, and that equals minus a half from the equation, and b is the periodic function here, and that is a half, because that's a half 1 over 2 times x, and c is 0. That means there is no horizontal translation or shift. D is also 0. That means there is no vertical translation or shift, which implies that the curve will lie on y equals to 0. First thing we need to find is the amplitude. So we say number 1, amplitude. For that we do modulus of a, and modulus is minus a half, because a is minus a half, so you do minus a half modulus, and that is a half. So we just want the magnitude of a. That's what we want. We don't want the vector of a. Number 2 is we have to do period. So the period of the function, so period is equal to 2 pi over b, where in this case, if you look at a y equals to sine x. This is a parent function, and if you sketch that graph, it starts from 0 all the way to 2 pi. So the period, the end here is 2 pi, and this is 0. That's where it starts. And so this is a period. The period is 2 pi. That is when it completes one oscillation. So that's one period before it starts to repeat itself. We need to find our period. In order to do that, this one is 2 pi over 1, because b is 1. In this case, a is 1. So this is plus 1, this is minus 1, and that's plus 1. But the period is actually 2 pi over 1. There's a 1 here. And for us, it's a half. We don't have x, we have x over 2. So that means our period is 2 pi over a half, which equals 2 pi times 1 over 1 over 2, which equals 2 pi times 2, which equals 4 pi. Number 3, what we need is x scale. So for the x scales, we take period that we just got and divide it by 4, because there are 4 quadrants in a sine function and cosine function. There are 4 quadrants. So in this case, you will have the period is 4 pi divided by 4. That's first quadrant here, 1, second, third, and fourth. That's why. And so you then divide it by 4, you get pi. So the x scale is pi. And number 4, we need to find the start of our function and the end of our function. At the start of the function, we set x to 0 here. And at the end, because the period is 2 pi, so we set x to 2 pi. We have to set what's in the bracket here to 0 for us as well. So x over 2 equals 0, because we don't have x, we have x over 2. So we set x over 2 to 0, and we set x over 2 to 2 pi. Therefore, Multiply both sides by 2, you get x equal to 0. 2 times 0 is 0. Multiply both sides by 2, you get x equals to 4 pi for the end. So the function starts at 0 for us and it finishes at 4 pi. So that's the first period. And the next period will be 4 pi to 8 pi. And so that's what this is telling us. Number 5 is, do we have any vertical translation? Which in this case, none, because this is plus d. D is 0. That means y will be equal to 0. That's where the curve will lie on. Y equals to 0. So those are the first points that we need to take care of whenever we're doing the sketching of sine curve or cosine curve. Okay, so we've got our graph now planned. And first of all, we know the starting point x equals to 0 and the end point is pi over 4 pi. And we got the x scale that tells us that we add pi every time. So you look at the start and then you can see what you add to get your 4 quadrants. So the graph is a reflection because A is minus, so it's been reflected from the positive start to the negative start, So it's a reflection. And the graph is from going from 0 to 2 pi. It goes from 0 to 4 pi, which means it's been stretched because B, the value of B, so this is B, it's between 0 and 1. If B is between 0 and 1, it will stretch the graph. And if B is greater than 1, it will squash the graph along the x-axis. So the first point is 0 here. So that's what that's telling us. And then add a pi to the next critical point. And that's where it gets to its maximum height here. But it's in the negative direction. So you pi, and then add another pi to the next critical point. So it's first quadrant, second quadrant. The third quadrant will be here, and the fourth quadrant will be there. So that's the first curve. And so we could draw that. So do not use pen to draw your graph, use pencil in case you have to rub it. Right, so that's the, and then it goes all the way from there to there, and then almost goes from there to there. So that's your first sine periodic first period. And then we could do another period to the left, or we could do another period to the right because it repeats. It's a continuous function. So let's do another period to the left. Okay, you start 0, you add another pi. So in this case, minus pi. Goes to the top there. And then back down. And to the minimum here. And then back to 0. So that's a turning point there. So that will come for that. And that's a turning point here. And that will go there. And that will just hit the. So that's your graph. You can see it's been, the parent graph is 1 and minus 1. This is a half because of the magnitude here. A half reflected because of minus. So squash vertically because of this. A is, again, it was squashed vertically because A is between. So if A is between 1 and 0, so that squashes the graph. The negative is just a reflection, it's just reflecting it. So the negative is a reflection. So you can write it down. So negative is reflection, and squash is A, vertically squashed, B, horizontally stretched if it's between 0 and 1, so that is stretch, and this one is squashed. Right, so that's what's happened there. And that's the graph of the y equals, so that's a graph of y equals minus a half sine x over 2. So always do your amplitude first, period. Work out your x scale, your quadrant. That's the quadrant here, divide it by 4. You divide the period by 4 for your quadrant. Always check out your start, set whatever in the function in the bracket to 0. At your start, whatever it's in the bracket, you set it to 2 pi for the end. Check if there's any vertical translation, if there's any. This one is plus 0. So that's why. So that's why this is 0. And that means the equation y equals to 0 is where the curve will lie. So this is y equal to 0. The x-axis.